So my name's Glenn Chisholm. I come from a company called Cylance. We're looking at the problem of malicious software. So everyone here has a laptop. Everyone's laptop, they make the assumption that, well, the things on that computer are stuff that we want running on their computer. And so, you hear this sort of discussion about attackers and the way attackers come into companies. And, one of the ways they come in and one of the ways they gain persistence is through this problem of malicious software. And so, as any intelligence startup does, we just picked one thing to work on first. We didn't try and solve world hunger. It's just looking at one problem. And so our problem is understanding software on endpoints and making decisions. So I think what's pertinent to this environment is, for us, data acquisition is a really important piece. And so that means we want to require as much binary code as possible. And so once you start doing this, you start to run into some really interesting problems, because obviously, you have a certain amount of binary code on every single one of your endpoints. Every single one of those endpoints has a degree of change that occurs over a period of time. And so you start to get this really interesting population of code. And of course, from a data problem and from a pure database and storage problem, it begins to be, well, how do you start to deal with this particular issue? Because you have 10 million objects where you have an average of 76 kilobytes per object. That's not too bad. You have 100 million objects, we have an average of 76 kilobytes per object. It starts to become slightly more problematic. And once you get to 1 billion objects that are 76 kilobytes per object, you start to sort of have reasonable amounts of data here and the ability to process and flow this data. And for us, it's not that we're collecting the data because, we just sheerly like to keep it and put it somewhere. I was making a joke earlier about a particular database structure we tried where we could get the data in, but we could never get anything out, which was problematic for many reasons, not the least of which was productivity. So for us, we have to be able to take this data and our approach is very machine learning centric. So we do take advantage of a lot of, newfangled buzzwords and things like deep learning, et cetera, but we do it, for the intention of actually solving a problem, not just to use newfangled buzzwords. And so in our case, binary structures themselves are really, really interesting. And, I'm sure all of you as database experts would have a pretty good idea of the construction of objects from compilers and linkers and the artifacts that are left over in this. And it becomes more interesting when you start to deal with this from a malicious software perspective. So to start with, you have a really, really nice source of data. We have all the wonderful manufacturers out there that write software that, depending on your perspective, it may or may not be malicious, but it's sold to you commercially and you pay money for it. And then we start to have attackers. And attackers are wonderfully diverse in their ability to write really crappy software and really, really quite elegant, quite beautiful software. And being able to understand this problem at a very, very large scale and start to understand what the concept of malicious software is. You get very much the commodity grade crapware that is, I'm going to try and steal your banking credentials and I'm going to make 20,000, 30,000, 40,000 copies of the same thing. And primarily that particular motivation has been driven by the security industry's response. As Rafi said earlier, when Code Red got created, and there'll be people here that were around when the original worms got created on Unix platforms, and Code Red and I Love You virus and various derivatives of these things. What you developed a problem where the security industry thought the issue was how quickly can we push a signature to as many endpoints as possible. Because if we can push a signature that says, well, this particular piece of software is bad, as fast as possible, we can get in front of the infection and we can actually curtail the problem. It's a reasonable response when you have one copy of something. But once the attacker looks at this, their response is a fairly low-cost response from their perspective, which is, well, I'm going to take the same attack and I'm just going to craft it in 20,000 different ways. So now the security group community has to find all 20,000 and then distribute all 20,000 as fast as possible. And of course, there are ways of compressing those signatures down into smaller and smaller numbers. The problematic issues are not when you're dealing with that. It's when you're dealing with issues where the attacker has a single copy of the software. And the single copy of the software is on your computer. in which case the security community is probably not going to be able to access that particular piece of software, because the chances of it being detected as bad, the chances of it filtering back into the community are very, very low. And even if it does filter back, someone actually has to understand that it's problematic. And you know, one of the problems you get with these complex attackers is they tend to exist in multiple worlds. You know, one of the discussions we have is, you know, you have a discussion with a group of individuals, someone in agro-science. It's like, well, there's absolutely no way that any form of sophisticated attacker is going to come and look at what we're doing. All we're looking at is crop yields. Doesn't appear to be at all interesting until you think about that from a commodities trading perspective and the ability to make a return on commodities. If you can steal that data and you can prime the market, you can make substantial amounts of money at effectively no risk, because the chance of you being picked up in that particular model is very, very low. So the most benign data becomes very interesting to a sophisticated attacker, and the ability to monetize that data is what matters. And so once you start dealing with attackers, and you certainly have nation-state attackers, and they have an entirely different perspective. An organisation like the one that we're standing in would certainly be the target of various nation-state attackers. But you also have very, very, very highly paid commercial attackers. And, you know, effectively what you're dealing with here is, from their perspective, an almost unlimited willingness to spend to develop the attack. So that's a long way of saying that you get a very interesting population of the concept of malicious. So for us, we have to retrieve as much of this data as possible. We have to obtain it. We have to understand and label and structure it so we can understand the populations that it exists. Well, we have to understand the population of malicious, and we have to understand the groups within that population that become interesting. And so you know, then we have to be able to retrieve this data at very, very high speed to allow us to bring this through machine learning algorithms to extract characteristics and content that becomes interesting, that allows us to build algorithms that are predictive. Because there's not much point in gathering all this data and trying to do something with it if we can't actually provide some form of prophylaxis to people after we've done it. And you know, there's a reason I say that, which is, you know, quite frankly, you can detect something that I'm doing, but you probably don't want me on your computer for a few minutes. You certainly don't want me on your computer for a few days, and you definitely don't want me on your computer for a few weeks. Because by then I've already got everything that I want. Even a few minutes is probably too much. We all know what you can do in a few minutes of code. So, you know, the problem for us becomes one of petabytes of data, flowing it through. And, you know, we're one of these organizations that can quite frankly only exist because of things that Google and Amazon, et cetera, have done in the last few years. We couldn't create an environment that allowed us to do this without, you know, structures like S3, and I know the Amazon guys were talking about it, you know, S3 and large amounts of S3 storage. I have the unfortunate benefit of paying Amazon for that privilege. But you know, again, it's really important because the ability to access that kind of material allows us to create a solution that probably couldn't have been created previously. And the ability to flow that data through, you know, through easily achievable compute, petabytes of data, and that allows us to build models that allow us to be predictive about whether or not we feel a piece of code is going to be good or bad. So we have this sort of, you know, very large data store, we have this very large compute, you know, environment, and then once we're done, what we try and do is we distill the learnings down to, you know, 40, 50 megabytes of code that we run on your PC before any file executes. So, you know, for us, you know, I suppose the relevance for this forum is mostly around the data storage and retention, the ability to retrieve that data in a reasonable time frame, and the ability to process that through compute. And I think, you know, part of the discussion was, you know, having a discussion around different architectures. In our case, you know, the different architectures come down to a particular application, and ours is an instantiation of an application that requires substantial amounts of compute and